Hello everyone, how's it going? Vasco here from the Angular University. Let's quickly implement the functionality that we mentioned in the last lesson. We are going to make sure that whenever we click a thread that is currently marked as unread, that not only the unread messages counter is set back to 0 and the red border is removed, but here this thread is also marked as read. And also we are going to send to the server the information that the thread has been read, so that whenever a user refreshes the application, it can see that the messages have been marked as read. So let's implement this. The way that we are going to implement this is we are going to start by enhancing the dispatching logic of the thread selected action. If we go here to the store, to the reducers, let's have a look here at the UI state reducer. So we can see here that the thread selected action has a reducer which is only implemented at the level of the UI state reducing logic. We are simply marking the current thread on the UI state. We are simply identifying which thread has been read. Now, besides this, we also want to add here at the level of the store data reducer. We want to start by adding here some reducing logic here as well. What we're going to do here is we are going to mark the current thread as having all the messages read for a particular user, the currently logged in user. That's the first part of the implementation. The second part of the implementation is we want to send a side effect HTTP request to the server that is going to mark on the database that the thread has been read for this user, so that we keep the database consistent with what the user is watching on the screen. Let's start with the first part. Let's implement the reducing logic of this action here at the level of the UI store data reducer. So we are going to add here a new case clause. We're going to say that whenever the action is of type thread selected action, we are going to define here, we are going to delegate the handling of this particular type of action to a method that we are going to create in a moment. So as usual, the method is going to be named handle thread selected action, and it's going to take two parameters. One is the state and the other is the action. So we have here an initial implementation of this reducing logic. We are receiving the current state, we are receiving the action with the currently selected thread, and we are creating here, as usual, a clone of the state, and we are going to return this new version of the state. So we are not modifying the state that is inside the store. Let's see how we will implement this reducing logic. What we are going to do is we are going to get the thread that was just selected. So we are going to go to the threads map and we are going to access the thread with the ID that was just selected via the thread selected action. In here we are going to access the participants map and we are going to look for the current user ID that is logged into the application. So we are going to need this information. What is the current user ID? And here what we're going to do is we are going to set the number of unread messages of this user for this particular thread, the currently selected thread. We're going to set this to 0. So let's see how we can get this missing information, the current user ID, from the action. Let's see where the action is being dispatched. We are dispatching it here at the level of the thread section, and we are simply passing in as payload the selected thread ID. What we're going to do here is we are going to make the payload not a number, but a custom type that we are going to define here. We are going to follow the same naming convention and we are going to call it thread selected action payload. This payload will have two properties. The first is the selected thread ID, which is a number, and the second property is the current user ID, which will be also a number. Now we use this type here in the constructor as the payload of our action. Now let's switch back to the thread section component where we were dispatching the action. So now we are going to get here an error because instead of a number we need to pass in an object. We are going to use the object shorthand notation. So this sets the selected thread ID property of the object. The second property that we need to specify is the current user ID. So one way of retrieving this missing information would be to do something similar to what we did here by retrieving the current selected thread ID from the UI state. Because we are already extracting here something from the UI state, let's make this a little bit simpler. Let's create here a variable UI state. And what we're going to do here is we're going to keep a snapshot of the UI state at the level of the smart component, because it's needed in several places. So let's start by removing this. The current selected thread, we no longer need this variable. It will be taken here from the UI state. We simply need to define here the selector for the UI state. We are going to do this. We are going to select the UI state from the application state, and we are going to subscribe to this observable. So here we are going to receive the UI state, and what we're going to do with it is we are simply going to store it here in this member variable. So whenever the store emits a new version of the state, we are going to store it here. Now we have kept here a reference to the UI state. To guard against any issues that this might cause, let's import here Lodash, and using it we are going to clone the UI state so that we are sure that we are not modifying the state inside the store. We're going to use the clone deep function of Lodash, and we're going to create a clone of the UI state. So in this case we could also have used object.assign, because this object UI state does not have nested objects inside it. But if it would have so in a future refactoring, then that would cause a problem, because object.assign does not do a deep clone of an object. Now going back to the thread section component, we now have here the UI state available. So here when we select the thread, we are going to be able to populate the current user ID with the value of the UI state user ID property. So we also need to go back to our template and we need to adapt it. So here we were using the current selected thread ID variable, and take a look at the integration between the WebStorm IDE and Angular. So we can see here that the variable is marked as unresolved. So what we're going to do here is we are simply going to use the UI state variable. And notice we have autocompletion inside the template. We are going to put here the current thread ID. And because this might be undefined at the startup of the application, we are going to use here the Elvis operator to guard against that possibility. So now that we have here the thread selected action being dispatched with all the necessary information to implement our reducing logic, let's go back here to our reducer. So we have here now a problem, which is the payload is now an object and not a number. So here what we're doing is we are selecting the currently selected thread. Now we have here the information of what is the current user. It's available inside the action payload. So we're going to use the current user ID. Now notice how this line of code is already a bit hard to read. It's hard to say what is going on without reading the whole thing. So what we can do at this point is we can add here an explanatory variable. This is the current thread. We are going to define here a local variable, which is the current thread. So this way our code is a bit more readable. We have extracted the current thread from the store data, and now we are setting the current user ID counter of unread messages back to 0. This is a good example of how sometimes it's better to define explanatory variables to help us read our own code later when we get back to a function, even if the variable is used only in one place. Now at this point we should get here a compilation error. It's important as usual to define the payload in the constructor as optional, otherwise this will not work. Another thing that we need to do is, and this is a consequence of the action type defining any as its payload. If we would run the program now, there would be an error. Now let's see why. If we switch back to the UI state reducer, we can see here that when we are handling the thread selected action at the level of the UI state reducer, we are assigning here to the current thread ID the action.payload. The problem is this payload is now an object, but because it's defined in the type definitions using the type any, we end up not having a compilation error. This is one of the characteristics of the type any. We can assign it to anything, including a number. In order to fix this, let's take instead the property selectedThreadID of the payload. And this concludes the implementation of our reducing logic. Let's now have a look at this in action in the following lesson.